Now this one is going to be a little bit more trickier. How many are the multiples of 4 and 6 at the same time? Okay, how many are the multiples of 4 and 6? We can find between 0 and 400. Okay, now the question is, how many are the multiples of 4 and 6 at the same time? Okay, the numbers must be a multiple of 4 and also a multiple of 6. So 8, it's not an option in here because 8 is a multiple of 4 but not a multiple of 6. And I want to know how many of those multiples we have between 0 and 400. And the reason I'm just putting those exercises is because the theory is very simple. Okay, the theory that we are discussing between arithmetic progression, it's something very simple. Okay, per se. I mean, the theory itself, it doesn't go very deep, but I just wanted to show you that we can make some very weird and hard-working exercises just with a very basic ones. The problem is that sometimes, depending on the school you are at, during the classes, the teacher just gives to you the traditional exercises, and he is counting that you are going forwards with that, and then at the exam he's going to put something else. Okay, and at least in my opinion, the beauty of the exercise, it is when you just learn as you just do the exam. Okay, because when you just do the exam and everything you just find there, it is what you have found during the classes, well, that exam has no beauty. The beauty is when you just have that exam that you were expecting to have like 8 exercises, but there are just 4. And so, oh, come on, 4 is very easy. But as we start to reading the exercises and to realize that you're going to have to think much harder on those 4 than if you had to think in 30 exercises. So that it is a very good exam in my opinion. It is one that you have to think and not just go in the exam and just start writing without thinking. Okay, because this is copy paste. Okay, you just copy it whatever you saw at the class and paste over the exam. That kind of exam is not good in my opinion. The one that's good is one that you just blow your minds, the one that it takes you almost forever, and it is the one that is a challenge for you. So the reason I'm putting those, it is to challenge yourself. Okay, so pause for a minute, 2, 3, 4, 5, 10, and then complete. Okay, now let's start from the beginning. What are the multiples of 4 and 6? Let's start to think like this. We have a 4, then we have an 8, then we have a 12, 16, 20, 24, 28, 32, 36, so on. What are the multiples of 6? Well, I'm going to put like 6, then 12, then 18, then 24, then 30, then 36, and so on. Okay, the ones we are interested are those. Okay, those are the numbers. So this is going to be like, this is a sequence we're trying to form. this is going to be our A1, this is going to be our A2, A sub 3, and so on. Okay? So our sequence in the end, it's nothing less than 12, 24, 36, 48, 60, and so on. Okay, between 0 and 400. Okay, and now comes the thing we have to think a little bit. What is going to be the last number? Okay, again, let's take that pen. Well, the number we are trying to look, what will be the last multiple of 12 less than 400. Okay, that's what we're going to find right now. Okay, you see, initially it was just a simple AP problem, but now we're trying to find about multiples of 12. And let's think through for a moment. Well, that number, let's call it x, it must be divisible by 12, right? Okay, and by doing that, we are going to see that the number must be divisible by 3 and 4. Okay, and what does it mean to be divisible by 3? Well, the sum of the figures must be a multiple of 3. Okay, and what does it mean to be divisible for 4? This is a rule. The last 2 digits must be a multiple of 4. Okay, for instance, if we have like ABC, so BC, last 2 digits must be divisible by 4, or just a multiple of 4. So it could end in 4, 0, 4, it could end with 0, 8, it could end with 36, it could end with BC could be 32, BC could be 80, and so on. Okay, now we're trying to find the last one, because we're going to need that one. Okay, why are we going to need? Well, let's go a little bit further in here. When you find the last term in here, okay, we're just trying to find the last term in here. When you find it, we're going to use this equation, an, it is going to be like a1 plus n minus 1 times 12, right? We know that it's 12 in here. Why do we know that? Well, because we know it's 12, 24, 36. So our D, our common difference, it is going to be 12. We need a1, right? We are trying to find n. Okay, this is our variable that we're trying to find in here. Okay, so we need an. Okay, now, well, it's going to be what? 300 and what? Right? Because it goes over 400. Now let's think for a minute in here. What should be the last one? Okay, and let's increase a little bit like this. Okay, in here. What should be the last one? Well, let's try in black. Something that it is divisible by 3. Well, 390 what? 99, it is going to be divisible by 3, right? Because 9 plus 9 plus 3, it is divisible by 3. This is going to be divisible by 3. Is it divisible by 4? No, it's not. Why? Because 99, it's not divisible by 4. But not divisible by 4. So not good. 98. Well, 98 is 98 divisible by 4? How can you tell? Well, we know that 100 it is divisible by 4. Okay, this is for sure. 100 is divided by 4. Therefore, the previous one before 100 it is going to be 96. Let's go straight and check 396. We know that it is divisible by 4 because 96 it is divided by 4. Okay, we don't have to check the hundreds. Okay, only the last two digits. Yes, let's see if it is divisible by 3. Well, 3 plus 9 plus 3 it is divisible by 3. Also divided by 3. So that is our number, 396. Okay, this is divided by 3 and also divisible by 4. Therefore, it is going to be divisible by 12. Now, we have found AN, and now we just put in here. AN is 396 minus A1, right? I'm going to throw A1 to the left, minus 12. A1 is 12. Okay, divided by 12. Okay, I'm just doing straight on. Okay, so divided by 12 plus 1. If you just want, you can just do it step by step, and you're going to see that in the end you're going to get this. This is going to be our value of n. Okay, so if we just do this math, you're going to get that n it is going to be equal 33, and this is our answer for the question. Now I'm going to do another exercise similar to this one. This is going to be number 10. Okay, but now look, now it's going to be how many are the multiples of 4 or 6 between 0 and 400. Okay, now the question is, it could be a multiple of 4 or 6. So it could be like 4, 6, 8, 12, 16, 18, 20, all of those. But there is a catch in here. I just want you to think about what is a catch, okay? Because you are not going just to add the multiples of 4 and the multiples of 6. It's wrong. If we just add multiples of 4 plus the multiples of 6, this is going to be wrong. And think for a minute, why is that? Think for a minute. What could that be? I'm going to pause in here. Okay, now, if you answer, because the multiples of 12, 24, they're being doubled, right? And we can't just double those numbers. So the answer, it is going to be like that. I'm going even to put in red. So the answer, it is going to be like this. Answer. It is going to be like this. The multiples of 4 plus the multiples of 6 minus the multiples of 12. Okay, and that it is going to be the answer. Okay, and what are the multiples of 4? Let's put it down here. Well, we have seen that the last one, it is going to be 396. I'm just use this equation, equals the first one, 4 plus n minus 1 times 4. Okay, and okay, let's just, I'm going to use a sub 4 here because it is the n for the multiples of 4. And in the end, if we just work out this, we are going to get that n4, it is going to be 99. and then we are going to have the multiples of 6, and the last one that's going to be divisible by 6, well, it must be divisible by 3 and also must be an even number. It is also going to be 396, okay, because this is divisible by 3 and it is also an even number. So this is going to be 396 equals the first one, which is 6, plus n sub 6 minus 1 times 6 now, right? Because we go from 6 to 6. The d, it is 6 in this case. And for that, we're going to see that n6, the multiples of 6 are going to be 66. And we have seen that the multiples of 12 are just 33, right? I'm not going to do it again. It is exactly this exercise. The multiples of 12, it is going to be 33. Therefore, our answer is going to be 99 plus 66 minus 33. And the answer, it is going to be 132. Okay, the exercise just alone like this seems very easy, but imagine if it is given to us just number 10 without the previous one. That would be a little bit trickier, wouldn't it? Okay, so exercises, be careful. Okay, we have to know a lot about arithmetic progression sequences, because if you don't, you're not going to be able to reconnect one part in the other, and you can see how complicated can get those exercises. So I hope you liked this exercise. I enjoyed making them, and we have a few more, okay, to the end of this segment in here. So see you in the next video, okay? Number 11, page 22. See you there. Bye bye.